Okay, so as promised, I'm going to go through a first project, a very brief data science project, which is going to have all of the primary aspects that I like to have in a data science project. So I'm just going to start off by making my basic directory. So I'm in my root folder. I'm just going to make the data directory, and there I'm going to put all my data. I'm going to create a code directory. I'm going to put all my code there. I'm going to create a notebooks directory, and that's where I'm going to put my Jupyter notebooks and any other notes that I have. And also, I might even put up reports that might be written in LaTeX or something else. And I could call these something different. Typically, code is something like code or code base or source. Data is data, typically. Notebooks could be reports or notebooks or writing, something along those lines to indicate these are materials that are made to present to other people, to present to other researchers. So that's those directories are now created. I'm going to do something where I'm just going to create a gitignore file, and I'm just going to copy it from my existing directory. So I've already written this. I'm just going to copy it from the other directory where I already have this project created. And I'm going to generically do that. I'm not going to code everything in front of you at the moment because it would take too long. And I'm also going to copy the data directory. Well, I'm going to copy the data from the data directory. And this should be the, I forget which one this is. I think it's davis.dat. Okay. So if we look at this, I have this hidden file, gitignore. So what does this do? Let's just first of all look at what is inside of it. So inside the gitignore file, it just says data. So each of the line in the gitignore gives you a location to ignore. So I'm going to ignore all of the files that are within the data directory. Right? And so what this means is that I'm not going to be able to add or commit any changes that are made to the data directory. So this is really important because it's very common for people to accidentally add a file that's within the data directory, and this file is extremely large, say a gigabyte. Right? Now suddenly this file has been added to all of your version history in your Git after you add and say committed on accident. Now when you try to push to GitHub, it's going to say that there's an issue with the, it's going to say this file is way too large to throw into GitHub. What were you thinking? Gitignore just prevents that right off the bat. And so by having a dedicated data directory, instead of mixing your data up with your code, is very nice. And you can always just throw your data into this data directory. And typically, we are not going to version things that are not really human readable. And I'm going to make an exception with Jupyter Notebooks. Some people don't like to version their Jupyter Notebooks, but I'm going to make an exception because I can read the raw Jupyter Notebooks because it's just a JSON file. More about that in a minute. So that's data and the data directory and gitignore. So if we look at our data directory, there's something in it. And if we just do more davis.dat, then we see that it's this file where each of these lines corresponds to a record for this is from the college scorecard, the U.S. college scorecard, and it's a different year, so there's a different file that this was extracted from, which is a CSV file. And this is the school year is the 96 to 97 school year. And this is publicly available data about each college. I extracted separately the California Davis, the UC Davis data. Right? So this is my data file that I'm going to be using. So I typically also add a readme to this. So let's just copy that over. So this is good practice. Good practice to add a readme into your directory. So let's look at it. So the readme is a markdown file. So we already talked a little bit about markdown in Jupyter Notebook, but it's a markdown. So we have some headers, for example. First project is the first header. So this is the title of my project, of my repository. And you should think of this as the front page of your repository, this README file. This is the thing that they're going to open up as soon as they clone your repository, or if they're looking on GitHub, this is what they see right off the bat. And it describes a couple of things. So it tells us what we're trying to do with this project, with this repository. It also tells us where to look if we want to see what the analysis is. So I'm going to save the analysis in a notebook file inside of the notebooks directory. And then it gives me instructions for how to get started. So we have to download the US College Scorecard, and then I have a separate munging script that I'm going to add in, and I'll show you how to do that with makefiles. And then munch will create the davis.dat file, which I've already added. So I've already done this. I didn't want to, because this data is extremely large, I didn't want to download it right in front of you right now. But and then it gives some basic ideas of how I'm organizing my my repository. And I'm specifying that I'm going to have a environments.yaml file for my content environment. I might not add this in this one because I didn't talk in detail about content environments. There are a few things that I'd like to come back to, maybe in a different video, which are how to use content environments and how to use branches with in Git. So those are sort of slightly more advanced material that maybe we can get to in a future installment. So let's look at, so we have the README file already. We have these directories. So I'm just going to, and I already ran git in it. And that's the only git command that I ran. And remember what that did is it created this .git hidden directory, which saves all the version history for this repository. So what I'm going to do now is I'm going to actually add something to my Git repository. Right now it's empty. There's nothing in it. And I can see that if I go to Git status, it's going to say no commits yet, nothing is tracked, there's untracked files that I haven't tracked. So I'll add these, git add the readme for sure, and why not the gitignore as well. And now I'm going to commit the things I've added. So what the git add does is it says I want Git to track this readme file. I want it to track this gitignore. Any changes to readme should get tracked in the future and should be added to a commit. So a commit is a given checkpoint in the history. So I'm just saying this is a place that I think is good enough to commit to the Git history. This is a good enough point for me to say, let's throw this in the history so that other people can revert to these changes that I've made so far. So typically what you want to do is you want to add and commit fairly often. If you've done work for a few hours or for the day, you're done with your work for the day, you add and you commit, and then you push those changes to the main repository. That's going to make it so that everyone stays on the same page, that there's not a huge divergence between the versions for Git. Okay, so let's commit, for example, our first project changes. So added readme. So here, what I'm writing is you have your commit statement is git commit, and then you have this -m as a message that you're going to add, and you want it to be relatively descriptive without wasting a ton of time trying to write a good message. This tells the other people who are pulling the changes from the repository a brief description of the changes that I've made in this commit. So this is the first commit, so I'm just going to say it added the readme, right? Okay, so now it's going to tell me the couple of things that the commit does. It adds the readme and the gitignore, and then I'm going to get, so now it's made this commit, and now this is a great repository. It has some files in it. I've added the readme. Now, what's the problem Well, GitHub has no idea that this repository exists. All these commands had nothing to do with GitHub. Now, I would like for GitHub to be able to to keep track of these changes that I've made, right? And so what I do is, if you look at the basic commands that GitHub asked me to do, it had an init, an add, a commit, and now I've committed my first commit. Now I'm going to add a remote repository. So git remote add is going to add GitHub as a remote repository. So I'm just copying and pasting that command. And this just says, let's make the remote repository, or sorry, the origin server this at this location. So we did that. Okay, so the next thing is I actually want to push these changes. So this is going to ask for a username and a password. So I'm going to type in my username and my password, ABCDEFGHIJK. Very good. Oops. Sorry, it's hard to do this while saying the password out loud. There we go. Okay. There we go. So now, I have added my, I've pushed these changes to the Git repository. I used my username and password. There are ways of caching. So I've set it up so that it automatically caches my username and password, but I have to type it in every once in a while so that I don't have it. So that if you get a hold of my machine and I haven't typed this in the terminal in a while, then you don't have access to my Git repository. Of course, having a password of ABCDEFG doesn't help with security issues. Okay, so so yeah, so that's that, and now I've pushed these changes to GitHub. So let's go look at GitHub and what these changes have done. So I've done all of this now. Let's jump over to the repository. Looks like the README is up here. And so the nice thing about GitHub is that they're actually going to render this README in a nice way. So this is a bit of a mess. I need to modify this README. So one thing about GitHub is it has a little text editor in it, which is kind of nice. So I'm just going to separate these out so that they get put into their own lines. This should work. There we go. Okay. So, and actually what the text editor is doing is it actually makes a commit on the fly. So if I go over to my terminal, then I can actually pull these changes and it will modify the README for me. So to pull changes so for the most part, that could have been a different user that was modifying that README file. And the way you add different users is you go over to your settings and you go down to manage access, and then you can invite a collaborator to your repository. So someone else could have changed that README file, and the procedure from my end would have been the same thing. They would have made a modification to the README file. I would have gone in, and I would have still had to pull. If I had made changes and then tried to push, it would have complained to me that you need to pull first, and then merge your changes, merge the changes and the conflict for that README file before you move on. Okay, so that's done. I have my data on my local copy. It's not in my, it's not on the GitHub repository, but I don't like to save base data in the repository. Something maybe this small I would add to the repository sometimes, but generally I leave it to the README file to tell the person how to get the data. So there were these instructions for how to get the data. Okay, so let's go to the code directory. So there's nothing in the code directory right now. And if I go over, so I'm actually going to add in a couple of things. I'm going to add in I'm going to write a code. I'm going to write a Python file that looks like the following. I've already written this, but you can imagine me writing this in real time. It imports this pickle. This is a package which allows me to serialize and save arbitrary objects in Python. And then, so you can imagine this is just allowing me to save files. I have, this file is broken down into different defs, so I don't have a base class here because this is so simple. All it's going to do is extract the data from the Davis. It's going to extract the data from that davis.dat file. It's going to go through and munch some of the data by creating an index, and then it's going to extract extract the variables from each line, and then it's going to extract the year from each line. So remember, this file was different years, different school years for UC Davis. This is coming from the college scorecard data. So it's going to start with this 1996 to 97, and then it's going to go through the remainder of these. And then it's going to extract all of these. It's going to extract these files and so on. And then, and actually, if you look at this, it only gets the index from the first file. Then I extract. Once I've extracted this data, I save it as a davis_ug.dat file, and I save it with pickle. Okay, so you might not get all of this. You might not be that accustomed to Python yet. You might still be learning. You might be an expert in Python. The basic idea is that you have this Python file that you've written. It's modularized in the sense that there's a bunch of defs and classes which you could call from, perhaps you could import from different, using this as a module. And then there's some base code that if you ran this file would run. And the way to specify whether something gets run or not in an import is by wrapping things in this if this is an __name _ equals this main, and then there's an _ here as well. And so this is a way for this file to change how it operates if it's imported versus if it's run from the command line. Okay, so I have this file. It's actually in a different directory right now, so I'm just going to pull it over. But typically, this is where I would sit down and actually write code, test it out, develop more code in PyCharm. So I'm going to copy it from first project, data code, data munch.py. Actually, I'm just going to copy everything over into here because we'll get to the make file in a second. Okay, so if we just look at this data munch, it has all of these defs, and it has this if _ name equals dunder main dunder. So what this this idiom here, this if name equals main does, is if I were to actually run this in with Python in the command line, then it would execute all of these commands that were after this if name equals main. So if I did say, if we did Python data munch.py, then it would run all of these commands. And what this would do is then it would extract all of the data and write the munch data, do all of these munching scripts, and write the munch data at the end. And it critically is pulling and writing all of the data to the data directory in the root. Okay, So that's one thing. I'm not going to actually do it because I would need all of the data to do this. And you can imagine that I've coded all of this in PyCharm. So now once I have this, I want a very streamlined way to instruct people how to actually execute these things and execute it in sequence. So if we look at the makefile, this is one way for us to be able to execute these things in sequence. So the makefile, the way makefiles work is there are these, it gives you make commands available to you, and then, so these are targets, and then you have prerequisites for the target. So for example, if I wanted to do make munch in the command line, it would run this data munch.py. So if we so we have to modify this. Let's open this up in PyCharm. Actually, let's open up this project in PyCharm. Okay. So if we open this up in PyCharm, then we have this makefile, and we have this munch, and then we have munch.py. So there's an issue with this. If we look at this, the file itself is datamunch.py, datamunch.py, not munch.py. So this is one thing that we could do, and it'll be saved automatically. You can actually configure it so that PyCharm will automatically add things to Git as they're modified. So everything that you're opening in here is going to be added and committed in Git. And so you can also look at our datamunch.py here. Yeah. And, you know, of course, the way that I did this was I wrote these things and unit tested them in sequence and tested out all of these commands before I wrapped it all up. But I'll spare you those gory details. Okay, so now we have a makefile that works, and if we were to say run, it's going to throw an error. But if we ran make munch, then it's going to run this file. Oops, there was an issue, of course. So one issue is that makefile, the way it's going to work is it's actually just going to run. If you do make munch, it's going to run these commands in sequence. And so if this isn't a valid command in the terminal, then it's not going to run. Just datamunch.py didn't work because the datamunch.py wasn't an executable. But if you write Python datamunch.py, then this should work because this is what you actually would run in the terminal here. So if we try it again, it does this, but it's still going to throw an error because we didn't have that data file to begin with, which is fine. We're not going to work with the full data right now. Okay, so so we have a makefile working, and actually I have a more sophisticated makefile that I'd like to have in here. So I'm just going to copy it over from the other directory. I think it's in here. Hopefully this is the right one. Nope, it's not any different. Never mind. Let's just change this back and then forget we ever did this. Okay, so now we have a makefile and we have code in the code directory. And the reason why we like makefiles is that now if someone wants to run if we want someone to run multiple commands, and some of these commands might just be in Linux, and some of these commands might be Python scripts, and so on, then we can just append them to the makefile and make it so that they can run everything very easily. For example, by just running the make all command, and that would reproduce all of our research, run all of the scripts that are necessary. Now, you can imagine that all of the scripts have been run, and they write all of the intermediate data files to the data directory. So let's go over here. I've already run these in a different trial. So I'm just going to add this in to my current directory. Okay, so you can imagine that I've run this script. I've pulled all of the much larger data set. I've run the script, and now I have this data davis_ug.dat. I've run my makefile. I've run make all, for example. It reproduced all of my computations, and then davis_ug.dat was created at the end. So now that I have this, I can start to visualize this data. I can pull this process and munch data into a notebook and then start visualizing the results. And typically in the code directory, that's where I would add, for example, the machine learning models and any other statistical methods that are somewhat computationally intensive. Those I would add to the code directory, because then I can run them offline. Maybe they're very computationally intensive and I could run them on a server, and then I could have all of the intermediate data being stored for the model, maybe its performance, and then I would open up a Jupyter notebook where I would describe the performance and the results of fitting the models. Okay, now we have our intermediate data, and now we have to populate a notebook. So typically here's where I would run Jupyter notebook, but first I already have a Jupyter notebook file that I've written, so I'm just going to copy them to my documents, and first project, notebooks, and this is analysis.ipython notebook to here. Okay, so I already have this notebook file created, but you can imagine me writing this from scratch. Right? So I run Jupyter notebook, and then I have the Jupyter server runs, and then I just create a new Python 3 file, and then I'll name it analysis.ipython notebook. To do that, it'll initialize as an untitled one. I'll just change its name using rename here, and then because I was using this as an example for Jupyter notebook, we had that first cell that I just deleted. Okay, so then I write, I'm just going to treat this Jupyter notebook as sort of the main document for this project. You might make a different decision. Maybe you'll treat your README as the main document, and you'll have multiple Jupyter notebooks that you want to refer people to within the README. That's perfectly fine. Just use whatever the context is. You'll just write your Jupyter notebook accordingly. So so I'm going to write, so this is my Jupyter notebook. Has a first markdown cell, then another markdown cell describing this describes the project, and then it describes the data a little bit, and then I have a basic visualization. This is, for example, the undergrad population of UC Davis over years. This is just for illustration purposes. And then I describe the figure that you're seeing here. I tend not to like to really try to make Jupyter notebooks beautiful. I feel like if you're really going to be committed to trying to make a perfect Jupyter notebook, then you are not going to want to use Jupyter. You're going to want to use something like LaTeX or some other much fancier markup language. So Jupyter notebooks, I try to strike a balance between readable and efficiently creating them. And so what that means is I don't mind having code sort of in line with the text, as long as that code is not too cumbersome. And it's also just to your advantage to write computationally intensive things in a separate Python file so that you can run it in the background instead of having your code running in the same place where you edit your document. So I tend to prefer just to have a Jupyter notebook be somewhere in between Python script and a finished report that you would say submit to a journal. It's somewhere in between those two. And so I don't dwell too long on formatting issues. I make sure that visualizations are free of distortions and they can communicate complex information. But I don't, for example, obsess about the font of the labels of the annotations in my plot. I don't really dwell on those sorts of things. And if I want a caption, I just write it in basic markdown right below the figure. So that's that creates my Jupyter notebook. You can imagine that I've written this in front of you, and then I've saved and checkpointed it. And now I can close out my Jupyter notebook. Oops. There we go. I can close out my Jupyter notebook just by shutting down the server. Now I have this notebook. I need to add this Python notebook file. I need to go back and make sure all of my code has been added in too. So I'm going to git add the data munch.py and git add the makefile. And then now I have these things added. I'm going to after I finish this video, I'm going to go back and modify the makefile so that it's consistent with what I have in the README. If you look at the README, for example, let's actually just jump over to the repository. In the README, I describe how to get started. You download the data and you unzip it in the data directory. And then if you want to, you can do the make munch within the code directory, and then it'll do these things. But critically, you have to there's going to be a few more things to make this work out. So I'll modify that. So currently, I don't have anything other than the README in the GitHub repository, and that's because I haven't committed yet. I've only added in these files. So let's git commit -m and write my message. Added the munching scripts. So I've added everything in, and this is not typical, and the notebook. So I've added everything in, and that's not really common. So I'm going to pull first, and then I'll push my things. So we've done all of this, and now if I go and look at my GitHub repository, then you can see, if I refresh it, you can see all of these things added in. We have the code directory. We have the notebooks directory, and we have the analysis.ipython notebook. If you actually go into GitHub and open up the IPython notebook, then GitHub is actually going to render it here. So this is something, a really nice service that GitHub has, is they actually render the Jupyter notebooks, so that this is now something that anybody who's on GitHub and looking at this can just view this data science project. And this is another reason why we really like GitHub for data science analyses, is that they'll render the README, they'll render the markdown in the README, and then if you want, you can link to the notebooks in your README, and then people can just go through and browse them. If your notebook files are really large, then GitHub is going to have a hard time rendering them. And so what I would recommend in that case is just separate them out based on the basic parts of your data science project. And you can see how this whole workflow enables reproducibility, because all they have to do is clone this repository. We haven't talked that much about this, but you can clone any repository that's public just by using the git clone command and cloning whatever this link says here. You can clone, and then you just follow what the README says, so you can see what the notebook files say in the IPython notebooks. And then hopefully you have instructions for how to get the data, and then how to process the data from the code directories. And the best way to enable processing the data and running all the scripts is through a makefile. And so hopefully this has shown you how to reproduce the data analysis You can run all the scripts in the code directory. You can look at the notebook files. Because they are Jupyter notebooks, they can open up these Jupyter notebooks and run them themselves and verify that all of this analysis is reproducible. So I would strongly encourage you to do this, to go through this example and try your own example, ideally with a partner who can also try to make modifications to the directory structure, to the files themselves, and then see what a merge looks like. So if someone else had made a real change to this code file while I was editing it, then I would have to pull, and then I would have to merge these by looking at the file, which is going to now have some the differences in line with my own changes. And then I would have to resolve those differences, add and commit that file again. If you're confused, there's a lot of really nice tutorials for Git on GitHub and through other nice sites. So I would encourage you to Google any issues that you're having, but at the very least, this will give you some idea of how to structure your projects.